obtain the following immediate or nearly so primitives. Okay, so these are going to be, some of them are going to be easy, some of them are not. Okay, so let's start with the first one. Okay, one is the primitive of 1 over the cosine square of x. Okay, this is the primitive of this is tangent. Okay, plus the c constant. Okay, you should know this by heart. Okay, that's one of the easy ones. Now, the primitive of the sine of x minus the cosine of x divided by the sine of x plus the cosine of x dx. Okay. Now, if in general, if you see this thing, the sine of x and the cosine of x, remember that we saw in one of the last lecture videos that you can make this change of variable. T is the tangent of x halves. Okay, and that changes the sine of x and the cosine of x into rational functions in t. Okay, watch the last video on change of variable to see how to do that. But in this case, they tell us that this is almost an immediate integral. Okay, and so if you look closely, right, you see that the derivative of the sine is the cosine, right, and the derivative of the cosine is minus the sine. So you can rearrange this and say this is minus, and then we have cosine minus sine divided by sine plus cosine, right? So now this is what we call g prime. This is what we call g, right? So the primitive of this is the logarithm of g. So this is just minus the logarithm of the absolute value of sine of x plus the cosine plus c. Okay, easy enough. If you do this change of variable, apply it here, change, do whatever you have to do, it will be long. You should get to this, okay? And you will if you do it correctly. Okay? We have the primitive of x, and then we can write this as a negative power, right? X squared plus 1 to the minus 5 over 2 dx, right? Now, so here is, let's call g of x is going to be x squared plus 1, right? And so we want g prime, this is 2x, right? So in order to have 2x here, this is just 1/2 of the primitive of 2x times x squared plus 1 to the minus 5 over 2, right? Or in other words, is 1/2 of g prime times g to the minus 5 over 2, right? Now the primitive of this is going to be g to the this plus 1. Okay, this is minus half 5 over 2 plus 1 is minus 3 over 2 divided by this. Okay, so divided by minus 3 over 2, it's the same as multiplied by minus 2 over 3. 2 and 2 cancel out, so you have minus 1/3 of x squared plus 1 to the minus 3 over 2 plus c. Okay. Okay. Now let's see. The fourth fourth integral is 1 plus the sine divided by 1 plus the cosine dx. Okay. Now again, if you didn't know this, you should change the variable t equals the tangent of x divided by 2. But here it says, hint, in 4 multiply and divide by 1 minus the cosine. Okay, let's do that. We multiply and divide by 1 minus the cosine. In the denominator you got 1 minus the cosine squared, which is exactly the sine squared. Okay, and then in the numerator you have 1 plus the sine times 1 minus the cosine, so you have 1 plus the sine minus the cosine minus the sine times the cosine, right? And so let's see. So this is equal to the primitive of 1 over the sine squared dx plus the primitive of 1 over the sine dx minus 1 over, and you have the cosine divided by the sine squared, and then you have minus the sine divided by the sine squared, you have the cosine divided by the sine. In other words, the primitive of the cotangent, right? So all of this, right, this is the primitive of the cosecant of x, which is minus the cotangent of x. This is the primitive of the cosecant. This is, sorry, the cosecant squared. This is the primitive of the cosecant, which we have seen in theory, which is plus the logarithm of the absolute value of the sine divided by 1 plus the cosine. Then we have this, which is going to be this is one of those, let's see, it's cosine divided by the sine squared, right? This is g squared, and this is g prime. So the primitive of this is minus 1 over g, okay, plus c. Minus is 1 plus 1 over the sine, which is the cosecant, so cosecant of x. And then you have minus, and this is, you can see, the logarithm of the sine of x plus c. Okay, this is this primitive. Okay, it's almost primitive. Sorry, it's almost immediate. But if you know all of these primitives for trigonometric functions, it's easy, right? And I encourage you to learn most of this because it's going to be very useful. Okay, so let's say the primitive of dx divided by 1 minus the sine, it says also multiply with 1 plus the sine. Okay, so you get 1 plus the sine here, and you have 1 minus the sine squared, or in other words the cosine squared. So the first one is 1 over the cosine squared dx plus the sine of x divided by the cosine squared. Now we know that the first one is a tangent. Okay, this is the first one that we saw, and this is going to be using the same thing is as we have seen in the previous one. This is the integral or the primitive of 1 over the cosine. Okay, so it's 1 over the cosine the second of x plus c. Okay, now let's see. 6 is the primitive of the square root of x divided by the square root of 1 plus x squared, but this is 1. This is easy because this is 2 you multiply and divide by 2, and then you know that 1 over 2 the square root of something and times the derivative here is going to be the derivative of 1 plus x squared plus c. Okay, almost immediate. Let's go for 7. 7 is the primitive of 1 plus the square root of 1 minus the square root of x divided by the square root of x. Okay. Now in 7 says you can write t equals the square root of 1 minus the square root of x, right? And so let's say we can expand this. This is t squared is 1 minus the square root of x. So in other words, the square root of x is 1 minus t squared. But we can also write 2t dt is going to be minus dx divided by 2 square root of x. But yeah, okay. So let me see. This is going to be the primitive of 1 plus t, and then dx divided by the square root of x is going to be minus 4t dt. Okay, so minus 4t dt. Or in other words, this is going to be minus 4t minus 4t squared. So the primitive of this is minus 2t squared minus 4q, so 4 over 3 of t cubes plus c. And if you undo the change of variable, you have minus 2, and you have the square root of 1 minus the square root of x squared. You can expand this if you want, and then you have minus 4/3 of wait a minute, sorry, yes. So 1 minus t squared is the square root of x, right? So 2 minus 2t squared is 2 the square root of x. So this is 2 times the square root of x minus 2. It's easier than that, okay? And then you have minus 4/3 of the square root of 1 minus the square root of x cubed plus c. Okay, this is this. Okay. Now let's see. Part 8. You have the primitive of the cosine cube divided by the sine to the 4th dx. And in 8 says write the cosine cube as 1 minus the sine squared times the cosine. So let's see. 1 minus the sine squared times the cosine divided by the sine to the 4th dx, and then we now expand. This is the cosine of x divided by the sine to the 4th minus, and then 1 over the sine squared. Now this is going to be, let's say, g to the 4 to the minus 4, right? And then here's the derivative. So this is g, the primitive of this is g to the minus 4 plus 1, so g to the minus 3. So the sine of x to the minus 3 divided, wait a minute, divided by minus 1/3, or multiplied by minus 1/3, sorry. And this is minus the cotangent, right? So this is minus, plus the cotangent, the cosecant of x. Yes, no, sorry, yes, so I forgot. This is going to be the cosine of x here. Okay, and now the integral of this is the cosecant of x plus c. Okay, and right, we have seen this before here. And let's see. And finally, 9 is the primitive of x cubed times the square root of 1 minus x squared. And it says in 9 write x cubed as x times x squared minus 1 plus x and expand. Okay, so let's see. This is going to be x times x squared minus 1 times this. So this is x squared minus 1 to the 3/2, or minus this, okay, because we have changed the sign here. And then we have plus x times the square root of 1 minus x squared dx. Okay? And so now we have this, which is, again, this is going to be 2 divided by 2, so minus 1/2, and also 2 1/2, right? Now the derivative of this is going to be this, so this is g to the 3/2. The primitive of this is x squared minus 1 to the 5/2 divided by 5/2, so divided, so 2 over 5 divided by 1/2 is minus 1/5, right? Or and then here we have 1 minus x squared to the 1/2 times the derivative of this, so this is going to be, or minus, right? Here's minus, so we have minus here. So we have minus the integral of this, which is 1 minus x squared to the 3/2 times, or divided by 3/2 times 2/3 divided by 2/3 is 1/3. Okay, and if you want, you can change the sign here, so this is 1/5 of 1 minus x squared to the 5/2, all of this plus c. Okay, and that ends the exercise.